Happy New Year, everyone! Welcome to the bright beginning of 2024. I'm Sherry. I hope this new year brings you high spirit and enormous joy. It's time to breathe new life into our journey with LeetCode Daily Challenge series. This year, we will together solve daily challenges and hone our programming skills. I will explain every code challenge using vivid illustrations and analogies to make every challenge a beautiful yet fun adventure. So stay tuned, and we are ready to start our very first challenge of 2024. Let's first read the problem statement and understand its requirements by analyzing some test cases. We have two arrays. G stands for greedy factors of children, and S the sizes of cookies. We need to maximize the number of content children by assigning each child at most one cookie based on their greedy factor. A child is content if they receive a cookie of size at least equal to their greedy factor. Also, the problem statement includes that the children greedy factor list won't be empty and both list lengths are within reasonable range. In the first example, we have 3 children to assign cookies and 3 cookies available. You can see the greedy level of each children is easily represented by the size of the cookie under the G list, the greedy list. The size of each cookie in the cookies list is also represented under the S list, the cookie size list. Before we start, the number of contented children is 0. A child can only be content if he or she receives a cookie that has the same size or larger size than this child's greedy factor. For example, we start from left to right and see if we can assign the first little girl a cookie. The girl wants a cookie of at least size 1. Thus, we can assign the first cookie in our cookie list, which has a size 1. We use check marks to indicate that the girl is satisfied with her cookie, and thus the number of content children increments by 1. And also we have assigned the first cookie in our list. We then try to satisfy the second kid in list. This boy wants a cookie that is at least size 2 big. However, the current cookie we are looking at, which is the second cookie in the list, is not big enough. It only has size of 1. Thus, we mark it with a red cross to indicate that the second cookie could not satisfy any child. However, we are not giving up the hope of assigning the second child a cookie he wants. We then look at the next cookie, the third one, with a size of 3. This cookie is big enough to satisfy the boy's greed, and thus we increment our number of content children by 1. Now, we have used up all the cookies in the list, and we have no cookies to assign since the pointer now is out of bounds. We return the number of content children as 2. By analyzing this example, we can come up with a greedy approach such that every child should receive the smallest cookie that meets their greed. Before we use any greedy approach, it is very important for us to provide logical proof for our greedy approach, because greedy approach, by its very nature, only aims for local optimization, which may not lead to global optimization. We need to prove that local optimization will finally lead to global optimization. The rationales behind our greedy approach are the following. First, we sort the kid list and the cookie list in ascending order so we can find the current least greedy child and also the smallest cookie easily. If the current smallest cookie can contain the current least greedy child, then why would we assign this child with a bigger cookie? We can save the bigger cookie for other greedier children in our list. If the current smallest cookie cannot contain the current least greedy child, then this cookie cannot contain any other child which is greedier than this current child. In our example, it would be the second cookie, which is crossed out because it cannot contain any child in our list. After we prove our greedy approach, let's quickly go through another example. We should notice that the test cases given in the problem statement can be very misleading because all the test cases provided have their arrays sorted. However, it is not guaranteed that we will be given sorted arrays since it is not explicitly stated in the problem statement. In a real SDE coding interview, we will need to ask clarification questions like, will the given list always be sorted? To make things clear, and then come up with a test case where the problem statement does not cover. In this test case, the child list and the cookie list is not sorted. Thus, we need to sort them in ascending order ourselves before we use pointers to iterate through them. After applying our greedy approach, the final result will be like this. The first cookie is too small to satisfy any child. The first two children are happy with their cookies, especially the second kid who gets an enormously big size 6 cookie. And there will be one child left unattended because we have used up all the available cookies. We return the number of content children, which is 2, as the answer. Now we will walk through our solution. First, we sort our list in ascending order. Then, we initialize 2 pointers and use them as the indexes to locate the current child and the current cookie of each iteration. We then apply our greedy methodology. If current cookie can satisfy the current child, we assign this cookie to this child and thus increment the number of content children by 1. We will increment child indexes by 1 because one child is satisfied in this iteration and we should move on to assign cookie to the next child. We also increment cookie index by 1 since the current cookie has already been assigned. If not, then we know that the current cookie cannot be assigned and gratify any child in our list. We still increment the cookie index by 1 no matter this cookie is assigned or not because it's no longer in our consideration. Eventually, we return the content children as the final result. The time complexity for this solution will be of n log n plus n log n. The n here stands for the length of list S, and m here stands for the length of list G. However, it is the sorting part of the solution dominating the time complexity because sorting an array of length k takes O of k log k. Therefore, our time complexity together becomes O of n log n plus m log n. The space complexity will really depend on which coding language you're using. Different coding languages will use the different sorting algorithm, and therefore they will use different amount of extra space to do the sorting. Here, we are going to use Python, and for Python, the space complexity will be O of m plus n. Also, don't forget that we used constant space for the 2 pointers and the answer variable. However, this is also dominated by the sorting part. Let's see the code solution for this question together. First, we sort both greedy level and satisfaction, or we say the cookie size level list in ascending order. Then, we initialize the answer variable and 2 pointers. We initialize the 2 pointers as 0 so that we can iterate from left to right. We use the child index as the pointer to point to the current least greedy child in the list. And also, we use the cookie index to point to the smallest cookie in our cookie list. We then walk through each cookie in the cookie list and each child in the children list. If the current child can be satisfied with our current cookie, we increment answer and children pointer. And we always increment cookie index to try next bigger cookie in each iteration, no matter the current cookie is assigned or not. Our while loop will end if our pointer go out of bound. After we finish our while loop, then this means that we have used up all the cookies or we have no children left to assign cookie. Now we can finally safely return our content children as the answer. This is the end of today's coding challenge. This question is not complex, but it's a very good practice of using 2 pointers to iterate through input lists and crafting and proving our greedy approach logic. I hope you enjoyed the video, and again, Happy New Year everyone! I will see you in the next challenge.